Okay, so welcome back. Hi. This will be part two of tornadoes. So, as I was saying at the end of part one, we're actually seeing more clusters of tornadoes or these outbreaks of tornadoes with 10, 20, 30, even hundreds of tornadoes over a very, very short amount of time. So, something kind of interesting. I mentioned earlier, back in the very first part, that we see the United States. The United States sees the world's vast majority of tornadoes, about 4 times more than all of Europe put together. And one reason for that is the United States is very poorly situated geographical wise, or geographically. So what happens is you've got the Gulf of Mexico to the south. You've even got the Pacific Ocean to the south as well. So you've got all of this moisture that can move northward. If the Rocky Mountains, instead of running north and south, were positioned east and west, we wouldn't have this problem whatsoever. However, there's no natural barrier in the United States to block all of this rich moisture coming out and warm air coming out of the Gulf of Mexico and even the southern Pacific. That combined with all of the cold, dry air that's funneling southward out of the northern states and also out of Canada, they tend to meet right there in the central portion of the United States, anywhere from Texas to Kansas to Nebraska, and those states right through there. So that's what makes up that tornado alley, because we've kind of got this confluence of these two different air masses, the warm, moist air mass, the cold, dry air mass, and they collide right there, and they really don't like each other. We start to see our storm systems form right there. And that's when we really start to see our tornadoes develop, and then we see these storm systems track as they move from the west to east, and that's kind of what gives us these outbreaks over several day periods. So really it's just that the United States is very poorly positioned, and we don't have a very prominent east and west boundary, such as the Rocky Mountains or something like that, some sort of mountainous obstruction to help block this air. Rocky Mountains run north and south, and they don't do much. So that's why we see the vast majority of our tornadic activity also across the central portion of the country and then off towards the east as well. As I mentioned, Tornado Alley, the next slide is kind of like, is it shifting? And there actually is some debate and some proof that it is. The traditional Tornado Alley, again, has been Texas, Kansas, Nebraska, Oklahoma, North Dakota, South Dakota. But we are actually starting to see more and more tornado activity across portions of Louisiana, Mississippi, Alabama, Tennessee, and even the northern areas of Georgia as well. So that is now what is referred to as Dixie Alley. So there is some evidence that Tornado Alley kind of losing a little bit of punch, and that storm systems are beginning to move a little bit further off towards the east, and we're seeing more activity again in northern Louisiana, Mississippi, Alabama, portions of Tennessee, and even northern Georgia, mainly north of Atlanta. So a little bit of kind of interesting tidbits there as well. So when do we see the vast majority of our tornadoes? We see the vast majority of our tornadoes in spring and then again in fall. We do have our primary severe weather season, however, and that is really April into May. That is when we see the vast majority of our tornadoes. In fact, if you looked at the next slide, from 1950 to 2011, the month of May recorded over 12,000 tornadoes. June was about 11,000, but really at that point, the main storm systems, again, you have to have that collision of warm air and also cold air. For the most part, though, in June here in the south, it's warm. If you're in Louisiana, Mississippi, Tennessee, Arkansas, it's very, very warm. However, the states a little bit further to the north, they're not quite as warm. They still kind of have that mix of that warm air and also that cold air. So by June, the tornado tracks and the vast majority of our tornadoes have pushed a little bit further to the north. It's just too really warm for that to happen here in Louisiana in June. But we do have a lot of tornadoes March, April, and May because we've still got that collision of air masses. However, by May and June, some of that track starts to move off towards the north. Still, however, a lot of tornadoes being reported in July and August. A lot of that, however, is either northern states or from landfalling hurricanes and the tornadoes that we see associated with those. We then have a little bit of a secondary bump again in October-ish, especially here, because again, we're starting to get that shift. We're going from the hot summer to the cooler fall. and eventually into the cooler winter. So again, it's that two clashes of air masses. So that's why we have our primary severe weather season in March, April, and at least the beginning of May. And then we have the secondary season around October for us here in Louisiana. So when do most of our tornadoes hit? The vast majority hit late in the afternoon. Now we can see tornadoes 24 hours a day. In fact, one of the worst ones in history took place in Natchez many years ago, right around the time of the Civil War, and it actually came through very early in the morning. However, the vast majority of our tornadoes are late in the afternoon. The next slide shows them anywhere from 4 o'clock to 5 o'clock is pretty much the peak. The reason for that is daytime heating. That provides that instability that we need for those thunderstorms to grow. Again, your big bubble of air that's going to continue to rise because it's warmer than that surrounding air. That happens later in the afternoon. Think about it. That's why we have all of those pop-up afternoon thunderstorms that we see here in the south during the summer months, because all of that heat and all of that hot air begins to rise. So it's a little bit more unstable later in the afternoon. So again, the vast majority of our tornadoes happen after 3 p.m., primarily by the time we get into 4 or 5 and also on into 6. But again, don't let your guard down because we do have tornadoes that happen really and truly throughout the other 24, 23 hours of the day. The next slide is just something that's kind of interesting. There's an organization called the Storm Prediction Center. It's part of the National Weather Service. They're located in Norman, Oklahoma, which is a good place to be located if you're dealing with tornadoes. And they put out what is called a convective outlook. They put it out for 3 days in advance. So if it's Tuesday, they'll put it out for Wednesday, Thursday, and Friday. But on that, they kind of categorize the risk of severe weather. So it will be a slight risk, a moderate risk, or a high risk. On this map that I showed here, there is a high risk. When they put out a high risk, they are entirely confident that we will be seeing severe weather. Back in 2000, I was working for a television station in Tuscaloosa, and it was about 84 degrees. It was December 16th. It was way too warm. And so we knew they were going to be putting out a high risk. And I actually called the Storm Prediction Center because they were late in getting it out. And the woman was like, we're having a big debate on where we should put it. They wound up putting 2 out, one for around Tuscaloosa, and coincidentally, the other one was for around Auburn, and both cities saw tornadoes that day. So if you see a high risk, that is just not somebody, crying wolf or anything like that. It really means that we are looking for a very big risk of tornadic activity to be taking place. So we're going to leave it there for right now. I'm going to come back with how tornadoes develop, kind of the 2 leading theories, and then we'll also talk about the EF scale as well.